you pull it back.
Absolutely, right? So I'm going to note on this one, right? I'm going to pull this back. If I pull it back a little bit, I get a result that looks like that. If I pull it back a lot, I get a result that looks like that. So if I'm changing my pullback distance here, all right, so this is the pullback distance. I just abbreviated it PBD, pullback distance. We'll measure in meters. Okay? What does it determine? So that's the independent variable. What is it determining? What is it changing? Okay? If I pull it back farther, what's the result?
Goes farther.
Yeah, so this is interesting. It does go farther, true? Now, I don't disagree with that. But I think what's really interesting is, watch what happens if, okay, we'll do it very specifically. I'll pull it back 10 centimeters. Do you have a sense of how far it went? Okay? I'm going to raise it up a little bit. Now, this is going to be interesting because I'm going to pull it back by 10 centimeters again. Ooh. Did it go as far? Now, it didn't go as far, but something did stay the same in both trials. It's not super obvious, but here's what I want you to notice. So now I let that one go, it makes it to about here. Is that cool? And if I put this down and pull it back, okay, it makes it farther along the track. But what's the difference between these two? Let me diagram it up, maybe you can notice. In the first trial, the track is shallow. Is that cool? And let's say it makes it up to about right here. In the second trial, it's much steeper, right? It only made it up to there. But what do you notice about those two things? So by making the ramp steeper, I'm actually changing how high up it goes, right? What if I took the ramp and I made it straight up and down and I did the same thing? It would go a very short distance, but the heights might always be the same. So what we're interested today, okay, what we're interested in today is the height change. And we're going to measure in meters. Is that cool? All right, so here's what I want you to do. So here's our situation the way we have it drawn, although it's backward, but we'll get over it. So there's the table. Here's the ramp. We're going to start the car back here. Let's go to here. Is that cool? So the thing that we're looking for, okay? The thing that we're looking for is the height change. So I think one of the easiest ways to do it is to measure from the back of the car here to the back of the car here, and this would be your distance that the car goes. You guys got that? This is going to take a little bit of thinking out of you. I know. And this height is the thing that we're interested in. You with me on that? So, we can measure the distance d here along the track. Okay? We can measure the distance d along the track. Here's what I want to know. If I know the distance d along the track that it goes, is there a way for me to figure out the height? So this is where I want you guys to really think about this, okay? All right, and you're going to have to check with your neighbor. That means you're literally going to have to turn to the person near you and have an actual conversation. I cannot be the only one talking. It's literally killing me on the inside. If I want to find out how high a car goes, I want to find the little h. I know I can measure the d value because there's a tape measure on the track. Is there a relation between h and d that I can exploit in some way? All right, so basically the question is this. If I can measure d, how am I going to figure out h? What else am I going to need to know? So check with your neighbor. All right, turn to the person next to you and say, hey, what do you think? And then have a conversation. More than, I don't know, what do you think? All right, come up with an idea. Maybe someone knows. Ready? All right, check with your neighbor, quick. Is there a way I can do this? There's got to be a way. How many math classes have you guys had? Like a zillion, right?
I've forgotten everything to the
So, there's a,
Well, there's a great moment to get in the game.
it's the same, I guess.
There's two really good answers to this. Okay? I want to know what you guys think though.
Because there's no matter what, like the speed. It's
So that's actually not a bad answer, because if you knew how far it went horizontally and how far it went diagonally, you could figure out the height, right? So Lucas said, look, just use the Pythagorean theorem. If you know the horizontal and you know the diagonal, you can find the vertical. Absolutely, but I don't have a tape measure down here. Okay, so that is a very, very, very good guess. I love where your head's at. Thank you for the effort. Is there another way that you might be able to think about it? You guys have so many math classes. So many math classes. You got to have an idea. Are there relationships between sides? I mean, given this as an idea, are there relationships between sides? Does the angle have anything to do with it? You could use like a similar triangle concept. Like, what are you thinking? Tell me what you're thinking. It'd be cool if it was one of those angles, right? It's a really small angle though. It's only like 3 or 4 degrees. Let's check my angelometer. She said, well, Owen said, he didn't say it, but I'm good like this. He said, I wonder, if I look over here, what if it's like at a 23-degree angle or a 16-degree angle? Could we explore the fact that it could be a similar triangle with one of these? That's what he said. He said it in his head, but I was listening.
Okay, gotcha.
Okay.
Yeah.
And I said, that would be cool too, except for this is actually really steep compared to this. And I said, this is only a 3 or 4 degree angle. And I said, let me check my angelometer app. So I have an app that tells me the angle. See? What does it say?
4 degrees.
4 degrees? Exactly 4?
That's 4 degrees. I can't see.
Okay, it says 4.7, maybe 4.8. Let's see if we can make it 5 degrees exactly. Oh, that's like 6.5 now. That was a lot. Got a little excited. Okay. So now it's 6.7 degrees. So it's telling me that this angle here, or this angle, so if I had the angle and a side, is there a way for us to find out what the other sides are?
Yeah.
Or not? I don't know. You want to use a sine or a cosine?
Wow.
Is that something you guys know how to do or no?
Yeah.
Yes or no? Yes? Yes or no? Sines and cosines? You're not expressing a ton of confidence. It's okay. It's not that big of a deal. So we have some functions that allow us to explore the relationships with sides, which is a very cool thing. So one of the definitions, if you plug this into your calculator, the sine of 6.7 degrees. All right? Put that in your calculator now and tell me what it says. Okay? Put in your calculator, make sure your calculator's in degrees, and put that in and tell me what it says. What'd you get?
0.4.
0.4?
Well, 0.404. 8. So,
I got 0.12. Is yours in degrees or is mine?
no, I'm in radian.
Oh, so frustrating.
Yeah, 0.116.
So 0.1, we'll call it 1.2. That's fine. It's good enough for now. So what does that mean? Well, what it means is that in a triangle where your angle is 6.7, the ratio, you guys know what ratio means? It means divide something by something. So what sine means is that you put this into your calculator, it tells you that if you take the length of this one divided by the length of this one, it's going to be this much. Is that cool? So what that could mean in this case here, okay, is that let's say that the height was 12 and this distance was 100. That means my angle would be 6.7 because the ratio of 12 divided by 100 is 0.12. It also means that, well, what if this was like 24 and this one was 200? That would still work, correct? Guys with me on that? So the whole thing is that if we knew this and you wanted to use sine, this is the way we could do that. Okay? Now, that's what that means. We don't have to do it that way. We can actually just do it, now that we know this as an idea, we could just set up our own proportions, like, I know you have 12 to 100 is equal to, well, if I pull this back now, oh, do you see that? Okay, so it came up here and it stopped at 120, and I let it go at 210. How far did it go? If it went from 210 to 120, how far did it go?
90.
Is that 90? So, question is, if I measured 90, what would your h be? So you could use this just proportion to figure this out.
Stay tuned. Have information about Social Justice League charity making more. Stay tuned.
The proceeds raised this week will be in support of the Grosse Pointe Animal Adoption Society. To start off the week, you will have the chance to send a snack to your favorite teacher on Monday and Tuesday. You can do this through the link in your email or go to the